Good morning. So here's another video by popular request from Tiffany Wall, my only groupie. Yeah, it's interesting that, like I've been saying before, that these videos have been up there 6-7 years and nobody's missed this particular one and nobody's ever asked me for it. But Tiffany did, and so I shall produce it for you guys. So, a couple of formulas to go think about. First one is what's called the arc length. So what's the formula for the length of this arc? Okay, whose radius is the circle. The radius of the circle is r, and the central angle is theta. So this is called the central angle right there. So the formula is S equals r theta. Okay, and theta has to be in radians. Okay, well, let's see if this formula makes sense. So imagine if you were to go around the circle completely. Okay. And so that yellow line would be the arc. And if you went around the circle completely in one revolution or one turn, then you know that theta would be 2 pi. Then the arc length would become r times 2 pi, which is equal to 2 pi r, and that is the circumference. Okay, so the formula makes total sense. All right, another formula that's not in here, but you should have studied this in geometry, so I'll repeat it here anyway for review, and that is the area of the sector. Okay, so what is the area of this little slice of pie here? Okay, the pizza, whatever you want to call it. Okay, and the area formula is equal to 1/2 r squared theta. Let's see if this makes sense. So again, if you are to go around the entire circle, then you will cover up all this area, okay, and theta would be 2 pi, and then this formula will become 1/2 r squared times 2 pi, which becomes pi r squared, which is the area of the circle. So again, both the formulas make complete sense there. Okay, why is this guy flashing at me? Okay, so those are the two formulas I wanted to teach in this one section. And then we go to something else that's relating angular velocity and linear velocity. Okay, it's a topic that many kids have a hard time understanding, but it's fairly simple. It's really relying on knowing just one formula. So here's a diagram that's kind of explaining what's going on. Okay, so imagine you've got a wheel. Okay, that's this guy here. Okay, and it's rotating on a road. Okay, going along a road. So as it rotates, and you can see the rotations here, like this guy here. Okay, and then it rotates out there, and rotates out there, and so on. So the wheel is actually moving forward in this direction. Okay, so that's called a linear distance. Okay, it's moving linearly along that line, and at the same time the point A is moving, so it rotates, and let's say it's rotating this way, and the point A comes here, then after a while it comes there, then eventually it'll come here. Okay, so you can see that this distance here is related to the circumference of the circle. As a matter of fact, the distance is exactly equal to the circumference of the circle. Okay, so what does this all mean in terms of linear velocity and angular velocity? So there are two formulas here that I've given you. Okay, and really I've given these to you only as intermediate steps. Those are not necessarily the ones to use all the time, but they're just intermediate steps. So you know from grade school, 6th grade, that linear speed is equal to distance over time. Okay, then a similar definition would be angular speed, which is angle over time. Okay, and how are these two connected? Okay, so we know that S is equal to r theta, right, from what I derived earlier. And if you divide both sides by t, okay, by time, then you get that this is the linear velocity, v, is equal to r, and then this guy is the angular velocity, times omega. So this is the key formula that you'll be working off of. Okay, And I've given it to you in English as well, because some people prefer that. I don't know why. Well, maybe it has some meaning. But here's the mathematical formula for it, okay? V equals R times omega. And let's see how we use that, okay? So here's a typical example, okay? So a bicycle is moving at the rate of 12 miles per hour. So highlight data that's given to you, okay? And diameter of the wheel is 26 inches. Well, the first thing you want to do is go put down the formula, okay? V equals R times omega. What do you know in here and what don't you know? Well, like I told you earlier, V is the linear velocity. So clearly, this stuff goes in here. And R is related to the diameter, which means that this guy, after some manipulation, has got to go in here. Okay? And that leaves you with this that needs to be found for question A. Okay? And so let's go do this problem. Okay? We know that V is equal to 12 miles per hour. So we're going to play around with the units. And we shall do that in a minute. Times R, and R is 13 times omega. Well, the units are not quite right. This is in miles per hour, and this guy is in inches. So we need to go from miles to inches. So 12 times 50 to 80 takes you to feet, and times 12 takes you to inches. Okay? And so this is equal to 13 times omega. So omega is equal to 12 times 50 to 80 times 12 over 13. And the units of this will be in radians per hour, because this guy here is in inches per hour. So I don't want per hour here, I want it per minute. So what I need to do is take this guy, and let me see if I can teach you the chemistry way of doing this. Over 13, you got radians per hour, and you want minutes, so you're going to go hours over minutes. Okay, so 1 hour is equal to 60 minutes. So you're going to divide by 60. And so your final answer, you can see, is going to be equal to whatever this guy works out to be, okay, radians per minute, okay. So let me pause here, get my calculator out, chug away on that, and give you the answer so that you know when you do it, if you do it, your answer is the same, okay. So, well, why don't I bring my calculator up in here, So clear that, and so I've got 12 times 50 to 80 times 12 divided by 13 times 60. So that's 974.7629, 974.7629, whatever, 292 radians per minute. So that's part A. And then in part B, what you want is you want revolutions per minute, RPM. Okay? So you know that when you go around the circle once, so one revolution, that's 2 pi radians. But you got these many radians, so let me change color. Right? You got these many radians. Now don't choose this number, okay? Use the entire number that's in the calculator. Okay? And so what you need to do is you need to take that and divide by 2 pi. And so if you do that, you get second answer divided by 2 pi. Okay, and so your answer for the second part is 155. So part B, it's 155.1393. 0.1393 RPM. And that's the answer for the second part. Okay. And I believe that's the last thing in 4.1 day 2. Yep. Okay. So pretty short video. Hopefully some people are watching. I know Tiffany is going to, but I don't know about others. Stop that.